So we have a wire carrying a steady current of 2.8 amps. The current in the wire, we'll say, is pointing straight up the wire. So current comes up this way. There's our I. Remember, the current and the length have the same direction. So there's the current in the wire pointing up this way. It's a little bit hard to see. Why don't we draw that right here as well? So I comes this way. There's I. The straight section of the wire is 75 centimeters long, so there's our length equals 0.750 meters. It lies in the XY plane at an angle of 30 degrees, so here's an angle of 30 degrees, and the uniform magnetic field is 1.60 K Teslas, so the magnetic field points out of the page, out towards us. So let's write down some of these things as vectors. So current equals 2.80 amps. Length of the wire is 0.750 meters at 30 degrees. Let's go for unit vector notation. So that's 0.750 meters times cosine 30 to get the x component, plus 0.5750 meters times sine 30 to get the y component. Put that through the calculator, we get 0.650 in the x direction, plus 0.375 in the y direction, that has units of meters. Our magnetic field is already given in unit vector notation, 1.60 in the k direction out of the page, and that's in Teslas. So we want to find the magnetic force on the wire. So we can do right-hand rule or our cross product. Let's do the cross product. But if we want to do the right-hand rule, we do I cross B to get our force is going to come down perpendicular. It's a little bit hard to do, a little bit hard to see. So I comes this way, B is out of the page, so our force comes down this way. So our force is going to look something like this. A little bit hard to draw 3D, so let's go ahead and do our cross product. Sometimes the math way is simpler. So magnetic force equals IL cross B. Our current is 2.80 amps. I won't write in the units just so it doesn't get too cluttered. Times 0.650 I plus 0.375 J crossed with B, which is 1.60 K. So we're going to break this into two parts. So we have 2.80 times 0.650, so this term first, times 1.60 I cross K. So that's the first one. We'll apply the distributive property, distributive. So we get 0.650 I crossed with 1.6 K. That's our first term with 2.8 out front. Then our second term is 2.80 times 0.375 times 1.60 times J cross K. So there's our whole term. Now we ask, what is I cross K? What is J cross K? A trick to remember is you draw them in a triangle, I, J, K, pointing from one to the other. I cross K goes the wrong way around the circle, so our answer is negative J. J cross K is going the right way around the circle, so the answer is positive I. So we multiply these three numbers in our calculator, and we get 2.91 minus 2.91 J. Multiply these numbers in our calculator, and we get 1.68. And that's in the I direction. Typically, we write the I first, followed by the J, so we can do that if we wish. You don't have to. And then, of course, we always include the units. So there's our force that we kind of figured out from the right-hand rule. It's got a positive x direction, negative y direction, and points down this way. Also, if you wanted to, you could do magnitude and direction, but since we have it in unit vector notation, we can leave it there.